Hello students, welcome to Aircraft Structures Laboratory. In this session, we will discuss how to determine the principal axis for an unsymmetrical section. So here, this is a cantilever beam having a Z section. This is unsymmetrical, and we have a couple of dial gauges. One dial gauge to measure the horizontal deflection, this dial gauge to measure the vertical deflection. Then we have 3 hooks. So here we have 2 hooks at station A and station B, it's our assumption. So this weighing hangers will carry loads such a way that there will be vertical loading, and this hanger, which is running over a pulley, will carry loads in horizontal direction. For measurement, we require a vernier caliper. We can determine the thickness of the section, so it is 2 mm. Then we have a steel rule which can measure the length of the beam. So it is 550 mm. Then flange width around 40 mm. Then web height 75 mm. So in this way we can measure the dimensions. So when we go to the experiment, I have suitable weights. Now I am loading 1 kilogram on each station. So I have 2 stations. So on station A and station B. Now initially, before weighing, always ensure the dial gauges are at 0. So I am just ensuring it is 0. So after making sure it is 0, the readings are at 0. Now we are going to weigh. So I am going to load weight on stations A and B. So 1 kilogram, 1 kilogram. So when you look into lab manual, you have a tabular column where we have a section called WH, WB. In the tabular column, WB represents vertical loading. Vertical loading will be constant all throughout the experiment. So it will be 1 kilogram on each side, so 2 kilograms will be constant. Whereas on this load, horizontal load WH, your load will vary. So we are going to apply loads in terms of 300 grams for each step. So initially it is 0. Now in your lab manual, so for the first reading, so 1 kilogram of vertical load, 1 kilogram vertical load. Now this will show some deflection in your dial gauges. That corresponding value, put it in your tabular column. So here you have a vertical deflection, and in this dial gauge you have horizontal deflection. Whatever reading you get over here, you just mention in the tabular column. So this is step 1. Then step 2. I have now 300 grams. This is 300 grams. So step 1, WH is 0, WB 2 kilograms. So WB we are not going to disturb, it will be the same. So step 2, 300 grams. Now for this 300 gram load, there is a change in reading in the dial gauge. So take the corresponding readings now. Now I am going to repeat this step further until I have a weight of 3 kilograms. So now I have 300 grams. Now next, further increasing to 300 grams. Now take the next reading, horizontal deflection, vertical deflection respectively. So I will repeat the steps until 3 kilograms. So for each loading, you take the measurement. In this way, you will get the horizontal deflection, vertical deflection. Further, using the theoretical formula, we know theoretical formula for principal axis, theta equals to 1 by 2 tan inverse of 2 IY minus IXX divided by 2 IXY. So compare the theoretical formula with the experimental result. So experimentally we will plot a graph between load and deflection, okay, in x and y axis respectively. Then with an intercept from at angle of 45 degrees, it will meet the curve. At that position you can take the theta value. So this is how you compare both the principal axis, the theoretical value as well as experimental value, and you can determine the principal axis. Thank you very much.